My dear students, today we'll discuss few more concepts related to signal system. That is, here we are discussing about the second module. In second module, so many concepts are there related to linear time invariant systems. That is, in that we are having discrete time LTI system, that is convolution sum, continuous time LTI system, convolution integral. So many other concepts are there in this second module. That is convolution. Convolution is very important concept. Convolution integral and convolution sum is important for important concepts which are there in the second module. Already we have discussed about convolution integral, and also we discussed what is linear time invariant systems. That is what is LTS system. The systems which are time invariant and at the same time if they are linear, such systems are called as linear time invariant systems. While discussing about convolution integral, we have discussed about in detail about what are LTS systems and how we perform the convolution integral. With an example, with a solution of the problem, we have discussed about convolution integral. Today we will discuss about discrete time LTS systems. The convolution sum. If the signal is in the form of discrete, you have done the convolution integral for the signals which are continuous in nature. At that time, we have to do the convolution integral. If the signal is in the form of discrete, you already know what is CT systems, CT signal and DT signal. If the signal is in the form of DT, that is discrete time signal, at that time, suppose we want to find out the convolution of that at that time we have to use the convolution sum. Here for discrete time signals, this is one example of discrete time signal. There is x of n, which is signal which is existing at 0 sample, the amplitude is 3, at 1 sample amplitude is -2, at 2 samples amplitude is 1. Like this is one signal which is in the form of discrete. Discrete means which are not already. So many times I told that what is CT signals, what is DT signals. That is discrete time signals means at a particular instant of time the signal exists, and other time it will not exist. At a particular instant only the signal exists. Such signals are called as discrete time signals. Now suppose if the signal is like this, then how we can find out the convolution? For that, we can't use convolution integral. Suppose in exam, if they give such signals or some equations, and we have to ask you to find out the convolution, at that time we have to use the concept of convolution sum, because the signal is in the form of discrete. Already I told that the signals which are there in the form of discrete, we mentioned that is x of n. Here we will write this that signals as x of n. It is signal. If it is signal is continuous time signal, then we represent is x of t. X of t is x of. From the equation, from the notations only, we should come to know the what type of the signal is. That is here convolution sum. The convolution sum, that is linear convolution, relates the input, output and unit sample response of the discrete time systems. That is, if the system is there, what's its input, what's its output, also the unit sample response. In convolution integral, what we have taken, it is which relates the system input, output and unit impulse response. Unit impulse response, there we have taken, that is h of n. Here we have to take unit sample response of the discrete time signals. Here for example, x of n, if they give like this, x of n is equal to 2 1 3 comma -2 comma 1. If this is signal, then we can sketch the signal like this. Here arrow mark indicates here at the signal 3 the arrow is existing, means it starts from that n value is 0. If n here arrow mark is there, therefore that value we have to consider n equal to 0. N is equal to 0 is 3. This is next one is n is 1. N is equal to 1 is minus 2. Then n is equal to 2 is 1. Like where arrow is there, that we have to consider that x of 0 or n value is 0. Therefore this arrow mark indicates the where the n value is 0. Therefore here there in the book he has given the derivation about how we obtain the equation for the convolution sum. Here this is the equation to calculate the convolution sum, that is in x of n equal to summation of x of x of n is equal to convolution sum formula. Then here that is I think they are written. Here this is y of n equal to summation of k is equal to minus infinity to plus infinity x of k h of n minus k. Here in the book he has given the equation for convolution sum as x of n summation of k equal to minus infinity plus infinity x of k. No, here he has x of n. This is also not there. Okay, no problem. This is the equation. Here we'll get the equation for this is convolution sum. Therefore convolution sum equal to y of n equal to x of n into h of n. Therefore the convolution sum y of n is represented as y of n equal to summation of k equal to minus infinity to plus infinity x of k h of n minus k. This is the formula to calculate the convolution sum. Therefore here you see here this is, if input sequence is x of n, output sequence is y of n, then how we can obtain x of n into h of n, where h of n is unit sample response. That is, therefore we can write x of n into h of n equal to summation of k equal to minus infinity to plus infinity x of k h of n minus k. This is the formula to get the convolution sum. Now we will see how we can obtain the convolution sum. We'll see an example how we can obtain example for understanding. I'm referring this book. This is also one of the good book, V2 book. This is V2 book. That is signal system by Dr. J.S. Chitode. It is a signal system which was said. This book, so many books are there like related to V2. They have given this such books, V2 books are available on almost all subjects in electronics. Here they have given the concepts very simple, easy to understand, and so therefore here this book is good to understand the concepts related to signal system. They give the concepts. They explain the concepts in simple way so that anyone can understand the concepts easily. Okay, this is also one of the best book. But whatever the textbooks are there, no, that is what I mentioned, that is Simon Hacking, and also these books, whatever these books are there, that is here you textbook, that is textbook is Alan B. Oppenheim, S. Wilsky, and S.H. Nawab, that is signal system. This is their textbook. Sir, as our principal sir, is taking the one class for one more section. Sir told that ask questions from this book only for test, for first, second, third test. You have to ask the questions from this book only. But books are there here. This book is also there. Reference book, Simon Hacking is there. Simon Hacking, and so many books are there. These are the Simon Hacking or this Michael Robert and Govind Sharma, like so many other BPL artists. These books are there, but you can't easily understand the concepts which they have given in this book. It is a little bit difficult to you to understand the concepts when you refer this book. Therefore, suppose you to understand the concepts, you have to refer such books so that you can understand the concepts very easily. Once you understood, no problem. At that time, you can refer those books. For understanding purpose, you have to refer this such books like Goats and Bakshi is there, and J.S. Chittode is there. They will write only the subjects related to electronics, and all that to the related to V2 syllabus. V2, how much is the syllabus? They will those concepts only they will write in the V2 books. These books are available in market. It will be available for 200 to 300. You can purchase such books, second-hand books. You can purchase in the market. Good book, good book for signal system, for reference purpose. Okay, we will see an example to understand the convolution sum. This in second module, the convolution integral and convolution sum are the two important concepts which are there in the second module. If you understand, then it is over, or then it is very good, very important. Definitely such questions will be asked in exam. One problem definitely they will ask related to convolution integral and convolution sum. That to 10 to 15 marks for each question. Definitely they will ask questions related to convolution integral and convolution sum. Okay, we'll see one problem related to convolution integral. That is example is convolve the following two sequences, that is x of n and h of n to get y of n. X of n, they have given this 1 1 1. This is x of some signal which is having that is 4 samples are there which are of amplitude 1 1 1. H of n is unit impulse, unit sample response, that is h of n, that is equal to 2 2. Therefore, but here you see in this example they have not mentioned here upward arrow mark is not they have mentioned. If they mention, then that from that onwards, that we have to take that sample as n is equal to 0. But since here in both the signals they are not mentioned about what is the arrow mark here. Here upward arrow is not shown in x of n as well as in h of n. Means that first sample in the sequence is the first sample. We have to consider it as 0 sample. First sample, since they are not mentioned the upward arrow. Therefore, x of k equal to 0, 1. Second one is also 1. X of k equal to 2 is 1. X of k equal to 3 is 1. That is related to x of n. Then similarly, h of n, that is we'll think as h of k equal to 0 equal to 2. H of k equal to 1 equal to 2. This 1 1 are the amplitudes of the signal. in h of n, you see the amplitudes of the signal samples are 2, 2. Then we know the convolution sum. What is the equation for the convolution sum? The convolution of x of n and h of n is we can obtain by equation, that is y of n equal to summation of k equal to minus infinity to plus infinity x of k h of k, the x of k into h of n minus k. Now here you see, now what we'll do for n is equal to 0, the above equation gives the sample of y of n. Therefore y0 is equal to summation minus infinity to plus infinity x of k h of minus k. Why? Because in place of n we have taken n is equal to 0. In the above equation, suppose you mention you would take the value of n is 0, then that equation becomes x of k h of minus k. Why minus? Means the value of n is 0 here. Therefore this will be the equation. Now they have given different sketches how we can obtain this convolution sum. Convolution, that is that summation should be minus infinity to plus infinity x of k h of n minus k. Now we'll see that one with sketches. They have given how we have solved the problem. This is your x of k, that is while doing the solution of this convolution sum at that time, here we'll treat this x of n as x of k. X of k equal to, what is x of n? That is 1 1 1 1, and starting from n value is 0 here. Since there x of n is there, here x of k towards k value will be 1 1 1. This is your x of k. Here h of n will treat it as h of k, and its value are 2 2. Here you see here this value here. What is x of n? Here x of n, h of n, like this 1 1 1, h of k 2 2. Therefore this is the signal, that is representation of the signal, discrete time signal h of k, which is having two amplitudes at the samples k equal to 0 and k equal to 1. Then when n is equal to 0, that means that h of minus k, above one is h of what? H of, you see here, this is your h of k. This is your h of k. H of minus k. Minus k means what? What we have to do? We have to folding operation. Folding, that is different operations on the, already we discussed about different operations on the signals. That is what? That is shifting operation, folding operation, scaling operation. That is h of k means if you take this side, then we will get h of minus k. Means if you take this side, reflect by folding. When you fold this like here, then it will be h of minus, it will become h of minus k. This will be here only, but this comes this side. That is, this is what? H of minus k. Therefore here if you take when we get the values, this is suppose here we want to find out the summation of h of x of k, h of minus k. If you take this and multiply by this x of k and this, at that time here when we get the result only when sample exists at the same instant, then only. See here, you suppose you see here this value, here it is 0 into 2. Why is 0 here? It is here 2 is there, but here no sample is there in x of k. Therefore here it is 0. Here also, if here, but here we'll get, here also the sample is there, here also sample is there. Therefore 2 into 1 we'll get, this is 1 into 2 or 2, 1 into 2, therefore 2. But here samples are there for 1 2 3 samples are there. But in you see here in h of minus k, is any samples are existing at the k equal to 1, k equal to 2, k equal to 3? No. Therefore these values will be 0. See here, 0 0 0. Why? Samples are not there at this instant. Also sample is not there. Here also sample is not there. Only at the instant k equal to 0, samples x in x of k is also sample is there. In h of minus sample is there. And there when multiple amplitude is 1, amplitude is 2, 2 into 1 equal to 2. Therefore summation of take all the samples. When we multiply all the samples, all samples value will be this 0 plus 2 plus 0 plus, because summation is there. Therefore we add summation means addition. Therefore this value will be 2 2. This value will be 2. Then now what we'll do, we'll shift this towards the right side. Suppose we shift this towards right side, means what we have to do, h of minus k. When shift we suppose we want to shift towards the right, then we that is nothing but that is when we shift that one, then we have to add that one. Suppose we shift left, then we have to subtract that one. Therefore h of k plus 1 we can write h of to plus 1 means when we shift right side, you refer the shifting property of the system. That time will come to know when how that is advancing, the delaying action. That already, if you know that concepts, you will come to know how we can shift the samples right side and left side. When we shift towards the right side, then we have to add plus 1 to this, plus 1 minus k plus 1. That minus k plus 1 we can also write as what, 1 minus k plus 1 will write as 1 minus k. No change, no problem. Like this, when we shift this signal right side by one sample, then this sample becomes here and this sample is shifted here. Therefore the newly obtained h of 1 minus k is what, that is at the 0th sample we are having one sample, at 1 k equal to 1 we are having another sample. Now what we'll do, we'll obtain the convolution sum for for h of 1 minus k. For h of 1 minus k, then how we can obtain summation of this, summation and in multiplication of this with this, because x of k into h of 1 minus k, summation of x of k into h of 1 minus k. Therefore you see here here's h of 1 minus k. Here at this instant here also sample is there, x of k. Here also at any k equal to 0 sample is there. Therefore we'll get 2 into 1 2, 2 into 1 2, and one more is here also we'll get 1 at k equal to 1 we're having sample. Therefore we'll get plus summation plus 2 because x of k h of 1 minus. Here we got this. But you see here at the k equal to 2, in x of k you are having sample, x of k equal to 2 we are having sample. But wherever, what about this h of 1 minus k, no sample. Therefore this will consider as 0. This is 1 into 0 only. Then one more sample is there here, but sample is there at value of k equal to 3. Here what about the at k equal to, what is the amplitude, what is the sample? No sample, therefore 1 into 0, no value, therefore 0 only. And so when we multiply all these samples with all these samples, we'll obtain, and when and we will do the summation, we'll get the result. We'll get here, you see, it is, we'll get the result as 0 plus 2 plus 2 plus 0 0. Therefore this value will be 4. Here with an example they have given how we, here we'll get the 2, here 2, but here 1 into 0 0 1, here also like this. How we'll get for summation of x of k h of 1 minus k, we got the value as 4. Next, now shift this h of minus k by 2 samples. One shift is like this. 2 samples means here h of k shift by 2 samples means here when we shifted by 1 sample, we got the signal like this. Suppose we shift one more sample towards this right side, then this will come here and this sample will come here. Means it will exist at k equal to 1 and k equal to 2. Here these samples will be, when they are shifted, they come here. And what is this sample? What is this signal? This is nothing but this is signal at h of 2 minus k. 2 minus k will get like this. 2 minus k like this. Then now we'll get the convolution sum. Convolution sum for when we, how we'll obtain that one? Summation of this x of k into h of 2 minus k. Summation of that. Summation of x of k into h of 2 minus k. Here they are given that here, but here you see sample is there at k x of k. But what about here? No sample. Here no sample is there here. Therefore, you get value 0 here. 0. Why? Because even x of k is there, but h of there is no sample at h of k equal to 0 in h of 2 minus k. This is 0. Therefore, but here x of k equal to 1 and here x of k equal to 1. Here also sample is there. There also sample is there. Therefore, 1 into 2, 1 into 2 will get 2. Here at the k equal to 2, here sample is there. Here is called, here it is also sample is there at k equal to 2. Then we 2 into 1, 2. Here there is no change in x of k. It is this sample remains constant. Here only we are changing, we are shifting the h of k. H of, before that it was h of k. Afterwards we were h of minus k, h of 1 minus k, 2 h of 2 minus k, h of 3. Like this we are changing the signal of the h of k. In integral also we are changing we are shifting the what? The unit impulse response. We are not changing the signal. That is, we are not changing x of t. X of t will be constant. We are changing, shifting, using shifting property in h of t. That is h of t or h of k. Therefore, we'll get the value of as 4. Then shift this h of 2, one more shift. H of k shifted by right by 3 samples. When this is, we obtain the signal like when shift by 2. Suppose we shift by 3 means one more shift here towards right. H of shifted to right by 3 samples. H of 3 minus if you not understood, then you refer the operations in the notes. I have given in detail about shifting property, different operations on the signal, delaying operation, advancing operation. That is shifting the signals towards right and left. At that time we'll come to know how we are shifting these signals, these samples. Therefore, when we shift this towards right by one more sample, that is right by three sample, then this will be to shift this. Now it is here at k value is 1, k2 k equal to is here. When we shift, then it will be at second sample k equal to 2 sample will be at k equal to 3 sample will be no sample at k equal to 0, k equal to 1. This is what your h of 3 minus k. Then obtain the convolution. How will obtain convolution? Summation of x of k into h of 3 minus k. When we do that one, here also, here you see at the instant 2 and 3 samples are existing, at instant 2 or 3 samples are existing, nowhere they are existing. Therefore 2 into 1 2 plus 2 into 1 3 will get, here also will get the value as 4. Summation of x of k h of 3 minus k equal to 4, like this. Now we will shift by 4 samples. Now we shift by 4 samples means we have to shift this sample one more towards this side. When shift by this, then this will be shifted means it will come to here, this will come to 4th position, value of k equal to 4. Therefore 3 4 at k equal to 4, we got here, you see that one, but there is no change. Now we'll get the convolution sum. When we get this convolution sum, you see here you see here no samples are there from 0 or left side or at k equal to 1, k equal to 3, but they are at there in 3 and 4. Here you see that here all values will be 0 only at the k value k is equal to the 3. We're having sample, this sample k equal to 3, k equal to 3 sample. Therefore 2 into 1 2. Then here is 2, but what about this 4 sample at k equal to 4, sample is there in h of 4 minus k, but in what about in x of k? At k equal to 4, no sample. Therefore here even though it is there, but there is not here it is sample is not there. When we multiply at k equal to 2 into 0, then value will be 0. Therefore what is the summation of x of k into h of 4 minus k is 2. But here in previous cases we have obtained 4, like we have obtained 4, but here it is 2. Why? Here when shifted here, there is no sample at k equal to 4. Like this, will by sketches how we are obtaining different values of this, like here also. Therefore overall the summation of samples of this product sequence gives y of 0 as like this. They are mentioned how at different values n is equal to 0. That is they are mentioned when n is equal to 0, how we are what value. When n is equal to 1, what value we got, that is n is equal to y, n is equal to 1 means what value we got, like this only they mentioned. That is here, that is first we got 2 here, 2 next that is 4 here also 4 here also, like this. How we have done calculation here they have given the explanation of that. When like this they are given, then what happens, then suppose we'll shift by one more value. That is now what we'll do, we'll find out shift h of k shift by 5 samples. Previously we shifted by 4 samples. We have got there is a when we shifted by 4 samples, one sample is overlapping at the instant of here at the k equal to 3, k equal to 3. But we shift this one that is h of 5 minus k will be, then this will come to 4, it will be moved to 5. at that time at k equal to 0 here, at that time you see here x of k up to k value equal to 3, the samples are existing. And when you shift this here, you see here, suppose in uh, this is your sequence x of k, this is x of k, h of k shifted by, then we'll get h of 5 minus k. Here samples are there here. Here this is the signal which is required, h of 5 minus k. Here you see here no signals are overlapping. Here signal is sample is there, but here no sample. Here our sample is there at k equal to 1, but here no sample. Here k equal to 2, sample is there in x of k, but here no sample. Here 3, sample is there, but here no sample. But here you see, here sample is there, but here not there. Here all sample is there in h of 5 minus k, but no sample. Therefore, the result is 0 because no samples are overlapping. Therefore, what is the value of x of summation x of k, h of 5 minus k? 0. No samples are overlapping. Like here we'll get, and also when we shift h of k shifted left now, because summation here convolution sum is what, summation of minus infinity to plus infinity. Here in equation you see summation convolution sum is equal y of n equal to summation of minus infinity to plus infinity. So far we have obtained summation for positive values. Suppose now see for negative values. Suppose suppose shift by left this sample. So far we have shifted this h of k right side. Suppose that h of k we shift by left side. This is h of k shift left side. Here suppose this is your h of k, this is h of minus k. You have shifted this h of, you have shifted right side. You have got this. Suppose this signal h of minus k we shift by left side. Left means what happens? This will come to minus 2, this will come to minus 1. When we shift the left side, we will get the signal will be like this. Is what when h of k shifted left by one sample. Therefore, here samples are like this. When we want to calculate the convolution sum when it is shifted left side, then no chance of overlapping between this signal and this signal, because it is existing towards positive values of k, but as we shift towards the left side, it will, this signal will exist, the sample will exist at negative values of k, Therefore, when we go on shifting left side, that is by one sample, two sample, three sample, these samples are going towards left side. There is no chance of overlapping between this. Therefore, result is always 0. X of k h equal to h of minus 1 minus k, that is nothing but summation of x of k, h of minus k is 0. Therefore, hence next samples of y of n for n less than or equal to minus will be 0 only. Therefore, thus the sequence y of n becomes as shown below. Then we'll get the y of n, the output as 0 0 2 2 comma 4 4 4 2 0 0. We'll get this. Here arrow mark is here because this 2 we obtained when value of n is 0. That's the arrow mark. This from means the whenever we plot the output, this is the signal will be starting from where n value is 0. That is like, or we can write this also, we can write as remove all this, only write this much only. What? 2 4 4 4 2 2 4 4 4 2. This is nothing but here, this is what were the result of the convolution sum. That is how we can obtain the convolution sum. Okay, this is how we have to obtain the convolution sum. This is one example related to how we can find out the convolution sum when they are given the x of n and h of n. Okay, in next class we will discuss few more problems related to convolution sum. Okay, thank you.